Hello, this session is to cover the DevPartner memory analysis tool for .NET applications. It is the green icon here, as you can see, for start with memory analysis. You also can do the same thing by starting the application via the toolbar full of icons here covering the different tools within Visual Studio. As you can see with the tooltip for the green icon here is to select runtime memory analysis. So I can start either from here or from here. Now what are we doing actually? Whenever we go in and actually hit this, instead of doing the regular start debugging we're accustomed to within Visual Studio, we're actually starting the application, but as we're doing so we're also hooking into it and injecting instrumentation on the fly with bytecode analysis and bytecode instrumentation. As you can see, my application has started up. In this example, it's a WinForm application. But also, you can see this window has popped up for DevPartner memory analysis to track memory leaks, which is references still being held when the session file is completed to let you know that that memory is still being held by particular objects and methods. There's the RAM footprint, which allows you to go in and look at the live RAM consumption of your application at any point in time in an idle state just by taking a snapshot. And then finally is the temporary object allocation analysis. This allows you to go in and find out where your intensive temporary object allocations are and how much memory is being used by those and whether or not they're being cleaned up in given cycles of the garbage collector. So with that, let's go back and look at memory leaks. There is one other step that needs to take place when you're doing a memory leak analysis, and that is to hit this little target icon here to start tracking memory. So once you do that, you'll notice that the shade changes a different color to let me know that I'm profiling memory now. I also can filter and look at the top 20 classes by instance count, size, in bytes, tracked instance count, or track size in bytes. So with that, I'll bring my application up, and you can see that as I'm working with the application, there starts to become a dynamically loaded list of the top 20 classes that are using memory. So with this, I will log into the app, and you can see the growth and decline of memory consumption as we're driving through the application. I also like to point out this is where you take the snapshot when we're ready to do so. This is where you can force the garbage collector, and this is where you can pause the display. So by forcing the garbage collector, what we truly mean is we're giving a hint to let the system know that it's okay at this point in time to go ahead and do a garbage collection cycle. So with that, we'll go ahead and go into the application just a little bit further, and I can either kill the app or I can create a session. So in this case, what we'll go ahead and do is create a session. So at this point I just hit view memory leaks, and what that does is it forces a garbage collection cycle, and then it actually collects the remaining stats out there, the remaining memory that's being held by the particular objects that have been tracked, and reports that back for you, as you can see back here. Now we'll go to the session files in a few minutes, but as we're here, I'd also like to go ahead and create, I'll stop tracking, I'll go ahead and create a RAM footprint snapshot, which is the same thing, very easy. Just go over here and view RAM footprint, creates a RAM footprint session file, and then while we're here we can go ahead and create a temporary object one as well. So with that, I can clear memory if I want to start tracking from here and clear the buffer, so to speak. Again, I can manually go in and force garbage collection cycles or send hints, as I mentioned before. I can pause, or I can go in and hit view temporary objects. So with that, now I've created session files, and I'm going to stop my application at this point. You will see a duplication here of a temporary object analysis session file, and the reason for that is because we've killed the session, so it knows at that point in time to go ahead and finish up. So there will be a session file listed there at times. So I do have my RAM footprint analysis, my temporary object analysis, my other temporary object analysis. So with that, we'll go ahead and remove one of these. And my memory analysis. So I've got my memory analysis, which is right here actually. So I've got my memory analysis snapshot that I took, my RAM footprint, and my temporary object allocations. So we'll briefly go through here and actually show you what these sessions look like and how to decipher further. This is the objects referring to the most leaked memory from within that session that I captured between the start and stop tracking. Also the methods allocating the most leaked memory. So I can go in from either point of view. Then I can go in and work my way clockwise from the upper left, which makes things a lot easier to deal with. And what I mean by that is you can focus on the app domain, the specific assembly, or if you want to go within the assembly to a specific file, you can do that as well. And you'll notice that as I choose a level in the tree, that I get a correlated or updated synchronized view of the methods as well as a graphical representation of those methods. I also can go in here and sort ascending or descending, which is the case in any column in any of the tools within DevPartner. And I can basically sort this and look by leak size. So I can see that on this command OK for the form login is my largest leak. So I can actually go in here, choose that, and then by choosing that I get a graphical representation based on that particular method. I can go backwards or forwards and see the percentages of memory that's still being held or considered to be leaked within each method, as well as on the flow downward or upward from the tree. So basically I can see the calls to the next level and then how much memory is being consumed in the next method down the tree. So from the parent-child relationship, if you will. So from in here I can see this is the one I'd want to drill into further. So I hit right click and view source. Then once I've done that, now I can simply just go backwards or forwards in here, like in this case going through this method that I've chosen, and see that the memory that's still being held is in this database connection. So what I could do at this point is I could actually right click and hit edit source and take this into the editor and make changes to realize that I need to go in and make sure that my database connection is closed. So just a good example of how this works and how you can go in and find these memory issues and go in and actually resolve them. So that's one way. There's two other prongs, if you will, in the three-prong attack for the memory analysis. We looked at the memory leak analysis with the references being held. We also have the temporary object analysis, and this is where I'd mentioned before when we created the session file for looking at the temporary object allocations. So I can go in here and I can look at the entry points as well as the methods using the most memory. So since we did the methods on the previous one, we'll go through the entry point this time. So now I can see my entry point, and I have one main entry point to focus on, and I can see its namespace, the execution count, and by the way, you can go in here and adjust any of these columns by going in and right clicking to the column heading and choosing which ones you would like to have in here. So from here, now that I've got it sorted, I can go in again and go up or down the tree and see the percentage of bytes of memory and temporary objects that are being allocated and held within each particular method. So I can continue drilling through, or if I get to a point where I know I want to focus, like this form login and we saw before, then I can go into view source, go into the source, and I can see the temporary object allocations, my line number, my execution count, and in fact here's an example to where we might want to put in another column such as temporary objects including children. So I'm going to go in and add that. So what this allows me to do is I can go in and see the line number, the execution count, the temporary objects that have been accumulated, and then we have what's called the short, medium, and long-lived size bytes. And basically this lets me know that I have X number of bytes prior to the first generation or generation 0 of the garbage collected cycle that have been accumulated. Then after that I can see when the second one kicks in that this is where I'm at, and then the third and more. So basically it allows you to see not only where these allocations take place and how many there are, but when they're being cleaned up and taken care of by the garbage collection cycle like you expect. So this is a good way to help find these particular memory issues. The third and final avenue is what's called the RAM footprint. So with this is where you can look at the live RAM consumption of the memory of your application at any point in time at an idle state. So basically you just take that snapshot like I showed you earlier in this session, and then I can look at the object distribution of the profiled and system objects. I can see objects referring to the most allocated memory and methods allocated that are allocating the most memory. So then I can drill in just like before. So once you're familiar and comfortable with one session, you've actually got all three avenues covered. There's just small differences. You still go in, work your way from the top in the clockwise direction, choosing what level in the hierarchy you want to work with. Then you go in based on that and choose the method you want to focus on by sorting, ascending, or descending by whatever column you choose. In this case, I want to look at the most live bytes. And then I can go backwards or forwards like we did before in the call graph. And by the way, the gold arrow reflects the critical path. So then I can go in here and hit View Source, and not only can I get live RAM consumption numbers and stats reported to me at the method level, but I can actually take this down even further into the line level and see that in line number 11 here I had one execution count, 1183 live objects, and these are the bytes. And then I can see the percentage within this particular method is on this one line of code, which is a little over 76%. So this is the way to go in and look at your RAM consumption and see how it's being handled. So basically, in a nutshell, what we looked at here is we create a DevPartner memory analysis session file by starting the application through the tool. It does on-the-fly bytecode instrumentation, gives you the ability to go in, run the application, view the memory graph on the pop-up that we saw, look at the dynamically updated list of objects and how much are being utilized by a particular, or memory that's being utilized by particular objects or methods, and then it gives you the ability to go in and create snapshots based on memory leak analysis, like we looked at here, temporary object allocations, and the live RAM footprint. Then it gives you the ability to drill down into the method level details and then down into the graphical representation and further into the actual code. So this gives you the ability to jump into the editor and resolve these troubled memory situations that you locate and want to go in and quickly resolve by automating the process and locating these through DevPartner Studio.